if we look at the equations in number 1, these are not functions because we can't solve for y explicitly. We have a y squared. Now, in order to be able to kind of look at graphs and get a better idea of what these look like, we can solve for y, but we're going to end up with 2 equations for each of these. For this one, if we divide both sides by 2, we get y squared equals 1/2 x plus 2. And then we take the square root of both sides, we end up getting y equals positive or negative square root of 1/2 x plus 2. So we actually get 2 different equations here that represent this curve. Same thing over here. If we take the square root of both sides, we get y equals positive or negative square root of x. So this one, square root of x, negative square root of x, should have kind of an idea of what that's going to be like. We're going to have a sideways parabola here. Each one is half of the sideways parabola. Square root of x looks like this, and negative square root of x would be the same thing, just flipped over the x-axis. Now, what happens with this is we're going to have a similar looking graph, and we could plug those into our calculator. Voila. Here we go. We've got square root of 1/2 x plus 2, negative square root of 1/2 x plus 2. Make sure you have the parentheses closed in the right spots, negative on the front. If we look at that graph, it's another sideways looking parabola once we graph both halves. And we can go back and put our other graph in here also. You can see we've got a little kind of boomerang looking shape in there is the region that we're trying to find the area of. So something kind of like this. And we're trying to find the area of this shaded region in here. Now, when we have this, we have to ask ourselves, do we have a function that's always to the right of another one? Or do we have a function that's always above the other one to figure out if we're doing a dx cut or a dy cut? So if we look at these, hopefully you can tell that we have one curve, our y squared equals x, that's always to the right of the other one. So we're going to have to use a dy cut. In order to do that, we have to have everything in terms of y. So really what we're doing here is we have to have our equations solved for x and writing them as a function of y. So our y squared equals x, that's going to be our right function. This is going to be our left function. Now, we need to find out where these intersect. We need to know the y values now this time, because everything is going to be in terms of y. So in order to find those y values, we can use substitution, just like we did on the last set of notes. We know x is equal to y squared. Well, we can put y squared in place of x here. So we have 2y squared equals y squared plus 4. So we're doing substituting that in there. So if we subtract, we get y squared equals 4. So y, take the square root of both sides, we get y is positive or negative 2. So that gives us our intervals. We're going from negative 2 to 2. That's our C and our D. Now inside here we need to take the right function minus the left function. But everything we're doing here is in terms of y. These are y values. We're only going to have y as our variable inside the integral. And there's going to be dy. It's a dy cut. So for this one's good. Our right function's already solved for x. So remember that was like f of y. Right? We have to write this function in terms of y. That's a y squared. Now, our other one is not solved for x yet. We have to subtract 4 from both sides. So g of y, our left function, would be 2y squared minus 4. And the is just getting x all by itself. So if we take our right function minus the left one, we've got y squared minus, remember we need parentheses around the second function, so we're subtracting the whole thing, dy. So this whole thing is in terms of y. These are y values, we have y variables in here, and this is dy. So we can kind of simplify the inside there. Y squared minus this, we're going to get negative y squared minus negative 4 gives us plus 4. Alright, this is one that's not too difficult. You can do it by hand, or you can use your calculator to evaluate this one. Either way, you should come up with 32 thirds.